So this is our experiment number 5, and its aim is to study various electrical lamps. Okay, so it includes halogen lamps, fluorescent tubes, CFL, sodium vapor lamps, neon lamps, incandescent lamps, LED bulbs and tubes, etc. So although this is not the exclusive list, it is, we have just mentioned few of the lamps, although in the market there may be existence of many more lamps, but we will focus on these only. So first of all, we will deal with the fluorescent lamp or tube light, which is its popular name is tube light. So the apparatus required is given here as choke, starter, tube, and single phase transformer. The rating is 250 volts, but in real practice, it may be company may give the rating voltage rating as 230 volts or 230 40 volts, etc. And its power consumption is 40 watts. Similarly, starter is 220 volts to 240 volts, and it is applicable for 20 watt, 40 watts tube lights. So tube light, which is small, is generally of 20 watts and 0.61 meters, and the tube light which is bigger is of 40 watts. And next is the single phase transformer. The role of the single phase, this auto transformer, is to ensure that the desired voltage is being supplied to the tube light. Next is the circuit diagram of the tube light, in which choke is connected in series with the phase supply, and capacitor is placed in parallel, and starter is also connected to the two electrodes of the tube light. Okay, so now we will go for the theory part of this tube light. So as I have just mentioned you that in earlier days there was two tube lights available, mainly of 20 watts and 40 watts of 0.61 meter length and 1.22 meter length, and the standard diameter was 25 mm. Okay, so the tubes are internally coated with the fluorescent material, and those fluorescent materials include mercury vapors and argon gas. So basically, when we talk of the principle of these lamps, whether it is the fluorescent tube or whether it is the neon lamp, sodium lamp, etc., the basic principle is that when we supply the high voltage, then the gas which is present within the glass of the lamp gets ionized. Okay, so when that gas is ionized, the electrons which are present in those gases moves to the excited states, or you can say higher energy states. Okay, but since we use mainly inert gases, for example argon gas or mercury helium gas, which is also inert in nature, or any other gases which are chemically very stable. Okay, so when the electrons move to the higher energy shells, what happens, they find that they are not in stable position there. Okay, so every atom or the electron want to be stable. Okay, so to increase its stability, what it has to do, it has to uh, come back to its original shells or octet to become stable. But if those electrons want to be more stable, then they have to give up those energy which they have gained on the application of high voltage. Okay, so and they do so. So that energy is in the form of rays. Okay, so E is equal to h nu. So the rays or the waves which is emitted while electrons are moving from higher energy shells to stable lower energy shells, while they are moving, they release energy of different wavelengths and frequency. Here E is equal to h nu, where nu is the frequency. So that light energy is reflected and it is passed on through the glass and reaches us, or reaches to the environment where that lamp is placed. Okay. So in addition to that, there may be some reflectors in the lamp which reflect the light to the external medium. Okay, for our beneficial. And similarly, we have seen that the incandescent bulbs or tube light or neon lamp or halogen lamp, sodium lamp, the light which is emitted is of different colors. So what is the fact behind it? It is simple that the since the amount of the energy released is different, E is equal to h nu. H is the Planck's constant, which is constant. Okay, so it all depends upon the new frequency, or you can say the wavelength of the light which is emitted. Since the wavelength is different and every different wavelength corresponds to different colors, so we see the different colors being emitted by different lamps. Okay, so the main difference between the all other lamps is the fluorescent material which is being used, the gas or mercury vapors which is being used, because the supply is same 230 volts in each. Okay, and the you can say reflectors which is used, it may be different. Okay, so the this fluorescent material can be in the form of the powder or gas. So this powder of the used in the fluorescent material is activated by the UV rays generated in the tube when high voltage is supplied due to choke. So these UV rays are generated, and these are also energy rays, and it helps electrons to go to the higher energy shells. And when we switch off the tube light or any other lamp, what happens that the high temperature, when we supply the high voltage, the energy is gained due to high voltage and also due to the high temperature which is being generated inside the lamp. Okay, so and the reverse process is applied when we switch off the lamp. So when we switch off the lamp, the electricity supply is cut and the voltage decreases, temperature decreases, and the lamp becomes cold. Electrons return to their energy cells, and they may again form the vapor form or powder form as a fluorescent material, or they may remain as a gaseous atoms. Okay, so this is the main principle which is applicable to almost all the lamps. The function of the choke is to produce the blast or the high voltage at the starting for starting the tube, and it may be iron core or vacuum core. Okay, so since choke is being used, coils is being used here, so the overall we can say that this tube light comes under the inductive load. So whenever we talk of the inductive load, it results in the low power factor. We have mentioned this in the our theory as well. So low power factor of 0.5 to 0.6 lagging occurs, although the desired power factor is 0.8. Okay, so to compensate this low power factor, we have to introduce the capacitive load or some capacitive bank capacitor. Now starter acts as a automatic switch. Initially it provides the short circuit that it pass on the current which is being supplied from the supply system, so that the electrons may go to the higher energy cells. And once that happens, initialization is then it roll is over and it is open circuit. Okay, so there are mainly two types of starters available in the market. One is the thermal starter and other is the glow type starter. Glow type starter is generally used for the domestic applications at our home. And although if we do not have the starter, we can simply short circuit that starter, it will still work. Okay, so working principle of the tube light is now clear to you. So these two cathodes and anode are the electrodes, and electrons flow from cathode to anode, and rest of the theory is same as I have explained. This capacitor which is across the bimetallic strip also suppresses the radio interference generated by the lamp. Okay, so this is also the purpose of the capacitor. Next is our halogen lamp. Okay, so these lamps are also classified based on the applications where it is placed. If we talk of the tube lights, it is generally used for domestic applications, in-house applications, or you can say in the balcony or the corridors. Okay, but halogen lamps are having the applications in bigger spaces, because this halogen lamp size is also big, although smaller ones are also available, but generally they are used for bigger applications, bigger positioning in public halls, or in the any roundabouts where red lights are there, sports hall, photo film, in hostels, or in stadiums. Okay, overhead projectors, operation theater lights, spread lights, etc. So, and all these lamps are available in different voltage rating. So it is a voltage rating of the halogen lamps is 6 volt, 12 volts, 24 volts, 230 volts. And similarly, the power consumption is also variable depending upon the voltages. So it is also listed here: 6 watt, 20 watt, 35 watts, etc. So the life of the lamp is around 2000 hours. So again, it is lamp is connected to the phase and the neutral of, and we may connect it to two-way switch. Okay, so in which one system is passed on to the MCB. Although again, MCB, as we have discussed in the previous experiments, that it is just a security aspect, safety aspect, although we may avoid as well. Okay, so it is also having the glass tube and reflectors as mentioned, and a porcelain holder. So inside the glass tube, this filament is of tungsten, and halogen vapors are added in the existing argon and nitrogen gas. Okay, so this is the main difference between these halogen lamps and the tube light. The gas which is used. So nitrogen is also there, and halogen vapors are also added, and high temperature is also achieved here, and its illumination is also good, 30 lumens per watt. So this is also one of the reason that it is used for outdoor applications, because of the amount of the heat generated. The application of halogen lamps, if we talk of the small size, uh, mainly in the jewelry markets. If we are dealing with the gold ornaments, the gold is naturally somewhat brown in color. So if we are using this halogen lamp of small sizes overhead ceiling type, so that halogen lamp light adds glare to the ornaments. Okay, so that is also the reason for using that. Similarly, if the jeweler is dealing with the say silver ornaments, then it is recommended that he should use white light, be it a CFL tube light or LED tube lights, etc., whatever it may be. Okay, so next is our sodium vapor lamp. So sodium vapor lamp is a gas discharge lamp which is uses sodium. Okay, so it is available in two varieties: low pressure and high pressure lamps. So low pressure sodium lamps has constantly maintained its position as most efficient light source available. Okay, so these lamps are known as SOX type. So what is this SOX? X is the numbering. For example, carbon dioxide, we use COT, carbon monoxide, we use CO. So similarly, X can be replaced by 1, 2, etc., depending upon the gas which is being used. So in the high pressure sodium lamps, there is additional elements to the standard mercury lamps, and the size of the high pressure lamp is smaller than the mercury lamp. Okay. So next is our neon lamp. It is the gas discharge lamp, and it is cooled cathode lamp. It consists of the glass bulb filled with the neon gas with a small percentage of helium. Okay, so again it is used for 110 volts AC or 150 volts DC. So it gives some orange pink colored light, and electrodes are pure iron, and they are separated few apart. Its illumination is also between 15 to 40 lumens per watt, and power consumption is also less. So while all these researches were going on, main purpose was to reduce the electricity bill. So our main purpose was that the power consumption should be less and illumination should be more. Okay, that's why these experiments on different gases and fluorescent materials were done. So as the discharge of the gas between the electrodes is of the nature of the arc, the lamp has a negative temperature coefficient. Okay, so you know the negative temperature coefficient, isn't it? As in the semiconductor cases, it has a negative temperature coefficient. So, and other labeling of the incandescent bulbs is the glass mount, support system, base contact wires, screw threads. Screw threads are generally used for so that the bulb is easily fitted inside the bulb holder. Okay, so this is the same incandescent bulb which was discovered by the Edison. Okay, so its uh, advantage is that it is easily available and it was the first to be discovered, and it's it is available in different wattages, 40 watt, 60 watt, 100 watt, and so on. But the disadvantage is that power consumption is more when we talk of the illumination it produces and heat it produces. Okay, so these are the disadvantages of this our traditional incandescent bulb. Okay, so next is our CFL, which is the compact fluorescent lamp. So when we were moving from the incandescent bulb to the CFL, so our main focus was to take into the considerations the drawbacks of the incandescent bulbs. So heat part was dealt with it. Second, the power consumption is less, illumination is more, it is soothing to eyes, and the fifth advantage is that since earlier we were having the bulb holders, okay, so the research was carried out to design the CFL in such a manner so that it can be fitted into the same bulb holder. Okay, so it is also available in different sizes, wattages, and shapes. Okay, so its labeling is also given here. It also uses the argon as an inert gas, and mercury vapors is also used, and the blast system is also provided as in case of the tube lights. Okay, so since it's available in different sizes, so based on our need, for example, if we need more illumination, we can go for the 36 watt CFL, and also to promote the CFL and later on the LEDs, the governments, what they have done, they used to provide the guarantee. 1 year guarantee was on the CFL, that if it get fused before 1 year, replacement was there. Okay, similarly for LEDs also it was followed. Okay, so fluorescent coating used is the phosphor, which is inside the tublet, which emits the visible light, and it uses 70% less energy. Okay, this is also a good thing about it. So although it is assumed that the or desired that the CFL should be blown to the full power instantly, but the reality is that as the aging goes, it may take time to glow its full value. Okay, so in our bathrooms we can use for the lesser rating, but in our reading room we can use for the bigger rating. So next is the LED bulbs and the tube lights, which is also shown here. Again, it was having the uh, holder, same holder principle, and PCB circuit was there, bulb shell is there, housing is there, and uh, it is based on the principle of light emitting diodes. Okay, so the incandescent bulbs, those filament produces the heat, it gets heated up and also produce the light in addition to those electron principles. But these LEDs, when it gets the desired high voltage, these diodes emits the photons. Okay, and those emits photons, which is light. Okay, so although same electron principle is also applicable here, because of the diodes, when we talk of the diodes, it is having the semiconductor system, which is also having the electrons, and thermal generated electrons is also there. But here we are mainly focused on the photons as a light source. So these electrons jump from one side to another through the PN junction, and when it is jumping, from one side to another when forward voltage is applied. So light is created. It is also having good life. It is energy efficient. It is safe. Temperature produces also less. Failure rate is also less. Therefore, the companies provide 2 years guarantee for these LED bulbs and tube lights. So different temperature is produced here, and also it is available in different ratings. Okay, so this is all about this experiment.